So thank you, everyone. My name is Chuck Ng. I'm your host today, along with, actually various distinguished speakers today. And it's Professor David Say, who's an expert on the security side of protocols. So in today's meeting, in terms of the agenda, we will have setting the stage. We'll have the speakers to share a little bit about themselves as a quick introduction. Following that, we'll have Tony, who will share a little bit about DeFi, what it means, to set the stage. And then we're going to have Professor David Say to talk about securities from the layer one perspective. We're also very grateful to have Harry, which will also talk about layer two on the perspective of finance. And then we will have a quick summary and then open up for Q&A. And then after the Q&A, we will have a breakout session, which will be specifically on the various topics, which we welcome you all to join at that time. So that's basically the rundown of the program today. So with that said, let me just also, as I said, acknowledge we have, Professor David Say. Please raise your hand, Professor Say. Thank you very much. Who is a professor of Stanford and an expert to share with us on the security side. We also have Harry. Harry, please wave your hand. Yeah, thank you very much, Harry. Harry is with finance team. And then we have Tony, which is with Pledge. Tony, please. So Tony, thank you very much for being co-host with the Berkeley alumni side of things. So Tony, maybe if you could, it'd be great if you can set the stage, share a little bit about DeFi and a high level overview about the different layers, if you will. So let me turn the time over to you, Tony. Thank you.
Hi, everyone. Thanks again for joining the meeting. It's great to meet everybody online over here. I'm a student of Dr. David Say. Now I'm running a DeFi protocol called Pledge. Pledge is a DeFi lending protocol. So later on today, Dr. Say, one of my favorite professors, will be talking about layer one security. Layer two is more on top of layer one. We call these programs layer two because it sits on top of layer one. We do smart contract programming. So Pledge and different other protocols, layer two protocols, and we will be talking about that more later on. It's great to have Chuck also with us. Chuck is BCAIA president, and Harry also is a good friend of mine. He's with Binance doing investment. Also, he is an EECS alum. So now I think we are all ready for this exciting talk for the DeFi. The security attack from Dr. David Say, right? So now let's get the ball rolling with Dr. Say.
Great.
Okay, cool.
Yes, David, please hand the ball over to you there.
Okay. All right. Can everybody see my screen?
Yes.
Yes. Okay. Yes. Thumbs up. Good.
Thumbs up. Yes. We can
All right.
see.
So thank you, Tony, and thank you, Chuck, for organizing this great event. And I'm very happy to be here to participate. And so as Tony already mentioned, a DeFi protocol is basically a smart contract written on top of a consensus engine. The consensus engine is also called the layer one protocol. And so that is my research area at Stanford. And so today, my discussion will be focused on consensus engine part. Now, what I'm trying to accomplish here in the 10, 12 minutes I have is one, explain what it means by a secure consensus protocol. Okay. Two, I want to give some examples of secure protocols and some examples of insecure protocols. And the whole point is to give you an idea that number one is very subtle and difficult problem to design a consensus engine especially in the permissionless decentralized setting where blockchains operate. And two, there are, however, some best practices that one can follow in order to design such a secure engine. So let me start. So a consensus engine is, at a high level, a pretty simple thing. So you have a bunch of nodes communicating with each other in a blockchain network. Each of this is a node. And you input transactions that you want to execute on this consensus engine at different nodes. And the transactions may come in different orders, and different transactions may come at different nodes. The overall goal of the system is to create a commonly agreed upon ledger such that this ledger is outputted at every node, and this ledger is exactly the same ordering of the transactions. This is very important because this is the heart of blockchain, is to come to this agreement that everybody agrees on exactly the same ground truth. And this is the basis of how Bitcoin runs, how all the other cryptocurrencies run, how smart contracts runs on Ethereum. They're all based on this agreement. Now, so what does it mean when I say a protocol is secure? So the first thing to observe is that the protocol can be attacked. So some of these nodes may become bad guys because, for example, they got bribed by the adversary. So the adversary acquires a certain amount of resources. They use this resource to bribe certain nodes in the network, and now they can attack the protocol. Okay. Now, the challenge of the consensus engine is to maintain security in the face of such adversary attack. And by security, I mean, everybody means two things. One is so-called safety, which means that the ledger that is agreed upon will never change. So imagine you transact one Bitcoin and the ledger change and says that your transaction is no longer valid. That's not so good. So safety is a super important property. But another also equally important property is liveness. That is, that this ledger will continuously grow as more and more transactions are executed. A protocol which is not live is no good because it will stop running and you cannot transact anymore on the blockchain. So safety is easy to achieve by itself because if you don't put any stuff onto the ledger, then you're always safe. Liveness is always easy to accomplish by putting everything you see in the ledger, and it's always live. So the challenge to design secure protocol is to design one that is both safe and live. Okay. So now I'm going to give a few examples of secure and insecure blockchain protocols. Okay. So everything starts with Bitcoin. Everything starts with Nakamoto. So Nakamoto invented Bitcoin in 2008. And this protocol is a very simple protocol. You have a chain of blocks, and miners keep on adding blocks to the tip of this chain to grow this chain. Now, Nakamoto, when he invented this protocol, he actually did not come with a proof of security. So here's my first point, is that security is not some experimental property that you can sort of experiment and say is secure. You have to mathematically prove that a protocol is secure. The reason why you need a mathematical proof is that there is infinite number of possible attacks that the adversary can attack the system. So you cannot just run a bunch of experiment simulation and say a protocol is secure. You will need to prove that all the possible attacks, you cannot attack the system. And Bitcoin have achieved this provable security property. Not by Nakamoto, but it was proved 5 years later in 2015. Now, in fact, Nakamoto did not give a proof, but he did give one example of an attack. You may have heard of this attack, so-called 51% private chain attack, where the attacker grows a chain in parallel to the public chain. But this is only one particular attack. Very importantly, this 2015 paper showed that not only that attack, but any attack cannot attack Bitcoin. And so this is good because Bitcoin is a very important blockchain. And other important blockchains like Cardano, which runs the ADA currency, is a proof of stake version of Bitcoin and also inherits this security property. Unfortunately, there is one very big drawback of Bitcoin. And the big drawback is that not only Bitcoin, but also Cardano protocols, all these so-called longest chain protocol, they're all very slow. Each block shows up many seconds or minutes. In Bitcoin case, 10 minutes every block, so very slow. And so one of the challenge in the field is to how to build protocols that are much faster. So in other words, you confirm transactions much faster. Instead of a few hours in Bitcoin case, maybe you want to confirm transactions in a matter of a few seconds. But once you speed up Bitcoin, then you can see the right-hand side is a block mess. And the reason for that is so-called forking. And the heart of the reason is because blockchain or Bitcoin is a decentralized protocol. And so therefore, because it's decentralized, you have communication delays. And this communication delay means that if your blockchain is running very fast, then everyone has a very different view of what the current blockchain is. And they start mining on different nodes, different blocks. And it causes this mess. And in fact, it has been shown that the security will go down from 50%, which says that you need a 51% to attack the system, to 0%. That means you only need a very small percentage of the resource of the network to attack it. As the speed goes up, as the speed of Bitcoin goes up. So therefore, Bitcoin is very slow. And so the next challenge is there a way to change the protocol, or so-called, in a technical jargon, change the fork choice rule that is a different rule than the longest chain protocol, and still keep the protocol secure, but fast. And many protocols you may have heard of, for example, Ghost, Conflux, which is a very interesting blockchain project, they all try to solve this problem. And unfortunately, because they're changing the rules to speed up the blockchain, it turns out that although the Nakamoto private chain 51% attack is thwarted, other attacks emerge to destroy the security system. And one example is the so-called balance attack. And so therefore, all these protocols have been shown to be either insecure or not proven to be secure. But this idea of speeding up the blockchain or increasing the speed of the blockchain is still a very important problem. And so there has been also other approaches to solve this problem. And a story I'm going to tell you a little bit here is the story of Gaspa. So you have probably heard that Ethereum 2.0 was launched about December timeframe. The beacon chain is run by a protocol called Gaspa. And this protocol is a brand new protocol designed by the Ethereum folks. And quite different from the other protocols I mentioned yesterday. To speed up the protocol is try a different approach. So first, it keeps the chain, which is shown here, to be slow, like Bitcoin. Okay, so the chain is not speed up, so there's not much forking. However, it is trying to have many validators to do very fast voting on these blocks on the slow chain, and thereby, hopefully, to quickly confirm transactions by the voting. So this idea is to avoid using a slow chain to avoid the forking block mess problem, but still have fast confirmation. Unfortunately, in a paper we wrote last year in a submission to the research Ethereum research blog, we have shown that in fact, the similar type of balancing attack as on Ghost can be executed on Gaspa. And so we've shown that this protocol is actually not secure. And the Ethereum folks, responded in last year, 2020, end of 2020, with a proposal to mitigate against this balancing attack. And so here you can see sort of the progression of design of the Ethereum 2.0 blockchain. You have a design, and then there's an attack on the design, and then you try to mitigate the design by changing the protocol. Okay. Now, however, I would like to stress that the fact that they can mitigate against this particular attack does not mean the protocol is secure, because it could, in the process of mitigating against this attack, you change the protocol. Maybe you open yourself up to another different type of attack. So to show that the protocol is secure, as I mentioned earlier, you have to mathematically prove it's secure. And in fact, currently we are working with the Ethereum folks to try to come up with a mathematical proof that the new protocol is indeed secure, or find another attack, in which case the design process continues. Okay, so that is the Gaspa story. So I've given you a bunch of negative examples. So at this point, you may think that, hey, you know, it's impossible or hopeless to get a fast blockchain. We showed about a year ago that this is not the case. And we've shown that you can actually construct a fast and provably secure protocol. And we call this protocol Prism. So in the remaining 2 minutes, I will run a visualization to explain a little bit the best practice employed in designing Prism to ensure the security property and yet make it fast. So Chuck, do I have 2 minutes to finish this?
Yes, please continue. You're doing great.
Okay. All right. Thank you. As I told Chuck, I try to keep track of my time.
Yeah, you're doing good.
Okay.
Great.
All right. So let's start the visualization here. Can everybody see the screen again?
Yes, we can see the screen.
Okay. All right. So here is the visualization of the Bitcoin running. So imagine now Bitcoin is running. These blocks are being mined. They're added to the blockchain. Okay. And the reason why Bitcoin is secure is because these blocks are added very slowly, so that the chain can be kept nice and straight with very little forking. So very strong security. But the problem is it's very slow. Okay. So what we did was, okay, this is very slow, and therefore we have to increase the rate of voting. And the blocks are coming in very slow, so the voting rate is very slow. So what we did was, instead of having one chain, okay, we constructed 1,000 chains. And these 1,000 chains are maintained by every single client in this new protocol called Prism. And these chains, they don't contain any transactions. Their only job is to vote for the blocks that appear on the green blocks. So now we have shifted the chain structure to the votes instead of to the transactions proposing blocks. And now the reason why our protocol is fast is because now you can see 1,000 chains simultaneously voting for the green blocks. And once each green block gets enough vote, they get confirmed and the transaction goes through. On the other hand, we have security, because each vote is protected by their respective longest chain. So the Bitcoin main concept is that a block, as they get deeper and deeper into the chain, they get more and more stable, and it's very hard for the attacker to change the block. We use the same idea as in Bitcoin, but apply that to not the Bitcoin chain, but to the voting chain, each one of them. And the votes get deeper and deeper as the chain grows longer and longer. And so they get stabilized. And so it's very hard for the attacker to reverse it. So the basic principle we use here is basically saying the following, that, hey, if I have a secure protocol like Bitcoin, instead of messing around with it, I should try to use it as individual component and compose these components together to build a more powerful, in this case, a faster protocol. Okay, so hopefully this example and the early example give you a feel that there are certain, although the problem of designing secure protocols is difficult, there are certain best practices one can use to try to achieve this goal. Okay, so that's all I want to talk about. Chuck?
Well, thank you very much. This is great. I love your visualization chart, by the way. I think it's
yes,
really...
and I have some blue color to show my support of cow.
Yes, and
this is a cow organized event.
Well, thank you very much. It is, you know, actually we're very proud that you know, many of us from Berkeley, but I have to say, the reason Berkeley is so great is because of Stanford as well. So that I have to acknowledge. So that's why being a professor and many friends at Stanford. So so thank you very much for sharing that. And I really enjoy your talk, Professor Say. And actually, so that with that said, I also you know, wanted to introduce Harry here because Harry will share after, of course, your really interesting talk on layer 1. Harry's going to share with us, you know, on layer 2, and I think it will be great from a you know, finance perspective. So, Harry, I want to turn the time over to you so you can share, you know, some of the updates on the layer 2, please. Thank you.
Sure. Hey guys, I think I think what Professor David Aziz just shared can actually be summarized as a blockchain trilemma. So there's always this impossible triangle between 3 elements, like scalability, like Professor David Aziz just mentioned, and also there's security and decentralization. So I think a lot of research effort as well as development effort has been put into solving this trilemma so far, and there are various of different consensus algorithm has been invented to actually to address the issue. So I think the most well-known one is definitely proof of work, which has been present for the longest time and has been proven to be very secure. And I think two of the biggest blockchains, Bitcoin and Ethereum, are still using proof of work. And also, I think there's also proof of stake, which was invented later, but it actually has been gaining a lot of adoption as well. I think like also for Ethereum, they're migrating to proof of stake because of the it's much more energy environmental compared to proof of work. And I think there's also a various of different abbreviation from the proof of stake, such as DPoS, which stands for delegated proof of stake, which are used by EOS. So I think what they are trying to do is they're trying to mitigate the decentralization part. So there will be, so for proof of work, Bitcoin and Ethereum are using, there isn't any limit on the nodes that are in the networks that can produce the blocks. As long as you can solve the mathematical puzzle, you are able to produce the block yourself. But for EOS, since they want to address the scalability issue more, like they kind of like mitigate the decentralization part. So there's only 21 validators that can produce a block, which are voted by all the stakers and token holders in the network. And also there's another two interesting derivation from POS. One is called Tendermint, which are used by the Cosmos blockchain, and also like NPOS, which are used by the Polkadot one. And the other than those two, like there's also a very interesting consensus called proof of authority, which all the validators are actually picked by the network, so they have the authority to actually produce the block. So I think all those efforts are trying to address the scalability issue of blockchain, because in order for blockchain to be put as a mass adoption, it has to be on a next level instead of like I think Professor David mentioned, like Bitcoin has a block time of 10 minutes. So like the transaction per second, like it can handle are very limited. So there's no way like it can be used for like general adoption. So at Binance, we saw this as an opportunity because we see the rise of DeFi last year. There are many people who are trying to use blockchain applications, especially DeFi, on Ethereum. But due to the scalability bottleneck of Ethereum, like the gas fee is really high. So for every transaction you want to execute, for example, a smart contract one, like it takes you around like at least $100, and also like the block confirmation time is extremely long. It usually takes about like 5 to 10 or even longer if you pay less gas fee, or like hours to confirm on Ethereum. So like the user experience are very, I would say it's a disaster for especially retail users who don't have like too much capital. So actually there's a community driven initiative from Binance called Binance Matching. So we saw this as an opportunity for to offer a new blockchain solution to the retail users, such that they can use decentralized applications and the special DeFi at a lower cost at a better user experience. So basically, Binance Matching modified the consensus algorithm of Ethereum to be a combination of DPoS and the proof of authority. So the result of it is because the block time becomes 3 times. So you get one block in every 3 seconds, and the transaction per second like can handle much more improved. So I think the peak TPS Binance Matching can handle is around 1,000, and the average TPS for Binance Smart Chain is around 200, which can solve most of the needs for decentralized applications and DeFi. So I just put a comparison chart here between Ethereum daily transaction chart and Binance Smart Chain chart. So you can see like for Ethereum, it has been in the space for a really long time, since 2015. So yeah, and it has been going through a long way. The transactions increased tremendously from nearly 0 in the beginning days, and nowadays it can handle around 1 million transactions per day. But for Binance Smart Chain, although it only started like in the middle of last year, like September, but you can see because of the improvement on the consensus, like the transactions per day nowadays, Binance Smart Chain can handle are at least 4 times of Ethereum. Like the peak, I think like it's like Binance Smart Chain can handle around 12 million transactions, which is almost 10 times what Ethereum can handle. And also, I think like this improvement has been proven to be quite useful and quite meet the actually what the users want from the unique address chart, which you can understand as a user number. So for Ethereum, for the 5 years of its development, I think it has been gaining around 150 million total addresses on its chain. For Binance Smart Chain, only although it's only half year old, but I think it's already gaining like 70 million, more than 70 million total users on its chain. So I think this is a really good a good task started by the Binance community, and which are proven to be quite useful at the moment. So I think you can, so this is the application ecosystem of Binance Smart Chain. You can see there's all kinds of wallet, different infrastructures like wallets, like toolings that are available on Binance Smart Chain, such that like developers such as Tony, I think Tony, they're actually developing on Binance Smart Chain as well. They can easily deploy their decentralized applications and DeFi's on top of it. So I think this is actually just many one of many. I think there's currently more than 1,000 applications running on Binance Smart Chain. But you know, I think but I think the whole value proposition of blockchain is also decentralization, because we want to decentralize and not let one centralized entity control all the stuff, the data and the rights to actually to write the block like in the ecosystem. So I think although like there are many different tasks and like efforts for to modify the layer 1 protocols, but which are so far proven to be quite difficult. Even so like there will be like trade-offs between those three elements. So I think there are also a new way people are trying to invent is called layer 2. So instead of like doing modifications on the layer 1 protocol level, many people are trying to invent on the layer 2. So there are different kinds of solutions have been proposed so far, such as state channels, sidechains, plasmas, and the latest rollups. So what they are trying to do is that they don't actually necessarily need to modify layer 1, but they are connect layer 2 directly to the layer 1, and they are improving the scalability on layer 2, which will be which the block the hash of the block will be signed and be transferred to the layer 1, so such that like actually the security level of layer 2 are shared with layer 1 as well. So I think Binance Matching actually can be considered one of the layer 2 as well. It can be considered as a sidechain to Ethereum, because like all the assets on Binance Matching can be pegged to and out to Ethereum through the there are many decentralized bridge, and also there's a Binance chain bridge, which are developed by Binance itself, utilizing its exchange infrastructure. But it's also one of the solution like the market current have. But there's also rollups, which are the most promising layer 2 solutions, which like share this share security and this decentralization with the underlying layer 1 Ethereum. But at the same time, because of it has its own chain, it has the scalability which much higher than the layer 1. So yeah, that's all for the layer 1 and layer 2s.
Very good. Well, this is fantastic, Harry. Actually, I really appreciate you sharing with us with the the blockchain trilemma, if you will. Now, actually, Professor Say, I want to on that note, since Larry, did a great job of talking about on the that trilemma, and I think you really kind of resolved the issue of security and scalability. There's the aspect of decentralization. So I wanted to ask your general thoughts on that, Professor Say, on the trilemma situation, and what are your general thoughts, and how do we actually solve those that is your thoughts in solving that issue?
Yeah, so the Prism solution is a solution to the trilemma.
Okay.
Because it allows decentralization, because it allows delays in the network. It also allows security. We've proven to be 50% security, and we have fast latency and high throughput. So I think we achieved those goals. Now, that being said, the protocol right now allows each node to scale the throughput very high. However, if you now want to consider a further layer of decentralization where each node is very poor or very low in communication bandwidth, imagine your cell phone, and you want to decentralize to that level, then I think further work needs to be done. And I think some ideas that Harry mentioned, like layer 2 solutions like sharding. I think sharding is another example. I think Harry did not mention that, but it's an example.
Yep.
Potentially allows a further decentralization to allow very compute and communication limited nodes to participate as well.
Yeah. No, wow, that's fantastic. Well, I'm glad that actually the research that you're doing actually addresses all these three elements. So Harry, actually, as a recommendation, I think that may be something that you guys can consider working with Professor Say, right? Potentially, the fact that Prism has a solution to the trilemma situations. I don't know if Harry, you want to respond to that?
Yeah, definitely. I think there's new. I think I think like this is actually a very research area. So I think there's like Prisma. I think it's one of the very most I think probably like the top of the state tag out there. So I think we're definitely willing to work with Professor David to try to to test it. But like David mentioned, I think like there's probably like a very like performance requirement on the node that's running for the Prisma network. So I think Yeah, but like I think for all the blockchain, especially on the consensus part, it takes some time to actually to test, to verify the security of it. So I think I'm pretty sure like in the next 3 or 4 years there will be like even more solutions coming out. I'm pretty sure Prisma will be one of them.
Yeah, well, very good. So, actually,
so let me say,
go ahead.
yeah.
Go ahead, Professor.
So I want to say a few words about sort of the landscape of protocols. So Harry mentioned like Tendermint, for example, which runs the Cosmo network. I think those protocols are very fast. They're from the so-called Byzantine fault tolerance family, BFT family, and they're well known to be fast. Our philosophy about this is that, those protocols were really built for sort of data center scale, small number of nodes. And it is not very clear to us whether or not they really can scale to a very large decentralized network. So our approach is that, hey, there is actually a real network that's been running for 12 years in a fully decentralized permissionless setting, and that's Bitcoin. And so our design is kind of leveraging off the robustness of Bitcoin and try to speed it up, but following pretty much the basic design principles. So I think that's sort of an interesting how things will shake up in the next few years in terms of the battle of the protocols.
Wow, interesting. Very, very interesting. Very exciting. That's a really, thank you for sharing that, Professor Say. Actually, so kind of talking like, I mean, it is, we're talking about security. So, on that note, I think there has been recent attacks, of course, in fairness to all kinds of network, including the ones in Ethereum, including, ones and I guess the projects, if you will, that are within the Ethereum network or Binance Smart Chain. On that note, Harry, do you want to just address, some of those attacks that have happened recently within sort of your network, for instance? I mean, what are most of those issues? What are the cause of those issues and attacks, and how have like what's Binance? What are you guys doing? It? What kind of things are you guys doing to mitigate those kind of risks and vulnerabilities?
Yeah, I think like so actually there have been like 3 attacks for the past months on some other projects on Binance Matching. So I think it's for people who don't use DeFi or blockchain very often. I think it's actually might sound pretty terrible, but I think it's actually I would say it's nothing that new or nothing special about it, because we've seen this a long time ago, since on Ethereum as well. So I think it's not actually about the security of the layer 1 protocol, but it's more, so it's not actually the attack on the blockchain itself, but it's more like economical exploit on the design of the application level stuff. So I think like what they are doing, it's like they're using the design mechanism behind the DeFi protocol. So they're manipulating the price such that they can sue different transactions on chain. They're basically exploiting the game design behind the DeFi protocol. I think that's a simple way to put it. But what's so special about those attacks is they're leveraging a new innovation design on blockchain called flash loan. So which means, so because of the design of blockchain, so in the blockchain world, the time are actually referenced as block time, like instead of like 1 second or 2 seconds. It means like so 1 second or like the minimum time frame in the blockchain world is actually block. So what flash loan means is it means like, for example, if we want to take a loan, like in the traditional world, we need to put collaterals. But in blockchain, if you take a loan and give it back like in 1 block, it means like you actually you don't even like take a loan at all. So what people can do is they can borrow, for example, 10 million since the start of the block, and they can do a series of transactions or attacks for those DeFi protocols, and they can benefit from it. And at the end of the block, they can just return the flash loan back to the lenders, and they can just benefit from the attacks. So I think that's actually the special thing about those attacks, is because for for those attackers, they can leverage flash loan to maximize their economical gain, and they can leverage because they don't need any, they don't need any collateral at all to borrow a large fund to start the economical attack. Yeah, I think that's what actually was special about those like exploits or attacks on Binance Matching so far. So
Got it.
so I think it's actually, I would say it's very common thing. So I think because for DeFi it's such a new space, like many developers, they're trying to deploy their applications like to attract and adopt users as soon as possible. So they don't actually have go through enough or necessary code audits. So I think probably like moving forward, as the more and more people are aware of those attacks, they will be more I think more conservative when playing with DeFi. So, and also I think like there are many, so for example, like many other projects that haven't been attacked on Binance Matching, they are going through a very large extent of code audit to prevent like the flash loan attacks, etc.
Great. So actually, I want to let people know we're going to have a breakout session shortly. So Patty, I think we will have a short breakout maybe for 10 minutes. So I want people to actually, Christina, can you make sure that